All right, so in this problem, we are being asked to find let's find it. How rapidly is the revenue increasing per day? Okay, so the change in revenue per day. So that to me sounds like dr dt. That now, if I go and look at my equation here, look, I have a revenue equation and there aren't any t's in it. So this is a big tip off to me that it's related rates. Now, that being said, the problem also warns you that to solve it using related rates. But if that warning wasn't there, right, we have our meaning that tips us off. So if I need to take the derivative of this function, r equals 3, 4, 6, 5. Sorry, try again. 3, 4, 5, 6. X minus 4x squared. Then I need to take the derivative of both sides with respect to t. So d dt of both sides, okay? Now, when I do this, I'm going to say, what's the derivative of r with respect to time? And that's always our favorite because it's literally, just write it down. It's dr dt, which is equal to. Now I have to do the derivative of both parts individually. So what is the derivative of 3, 4, 5, 6 x? Well, the constant multiplier rule says leave 3, 4, 5, 6 alone. And the derivative of x with respect to time is the exact same logic as what we just did with r. It's dx dt. No big deal. Now we have to do the derivative of negative 4x squared. Okay, well, so the minus 4 is constant multiplier, it's just going to stay there. So the derivative of x squared, now we have a little chain rule. This 2 is going to come out to the front and multiply the 4. So that's going to make it into negative 8x. Now I have to do the derivative of the inside. What's the derivative of x? Well, that would just be dx dt. And there we go. There's our derivative. Now, with word problems comes meaning. We say, okay, what do each of these things mean? And whenever we see a dx dt, we think change, okay? So if I say dx dt, this is going to be change in what? What does x represent? Well, x is the number of units that we're selling. So change in the number of units per change in t, which we said is time, and in this particular case, days. So change in days. So we're looking for some kind of number that has units that match that. Okay, so if we kind of scan through the problem and look for something with units of change in units per change in days, oh, look at this. We have our sales are increasing, which is good. That tells us our number's positive, right? Because it's getting bigger, increasing at a rate of 55 units per day. So therefore, we now know dx dt is equal to 55 units per day. And again, we want to make sure we think about, is that going up by 55 or is it going down by 55? Well, they said it's increasing, so that's going up. Okay, so everywhere I have a dx dt, I'm going to sub in 55. So the only other thing I need to sub in for is x. And we said x has the meaning of just units, the number of units we've sold. So as we look through here, we'll see, oh, look at this. It was increasing at 55 units per day when we had sold 300 units. So therefore, 330. So therefore, x equals 330 units. So everywhere I have an x, I'm going to replace that with 330. And so here we go. Let's say dr dt, the change in revenue per day, is equal to 3, 4, 5, 6 times 55 minus 8 times 330 times 55. And now, whoops, let's clean that up. And now is where our calculator is just going to be our friend. And here we go, 3, 4, 5, 6 times 55 minus 8 times 330 times 55. And that gives us dr dt is equal to 99,330. And do note, the problem does say round to the nearest whole dollar as needed, so or it might say something like that. So just make sure you think about what this means. Right? Think about meaning. So therefore, this is revenue measured in dollars per day. So this means our revenue is increasing at $99,000 per day, $99,330 per day. That would be, maybe we work at Disneyland or somewhere that has a high revenue in peak season. All right, I hope this helps, and best of luck.